Hello friends, welcome back. Today in this module we will study mechanism of bakelite. So let's start with this module. Now bakelite is a copolymer of phenol and formaldehyde. That is, the monomers of bakelite are phenol and formaldehyde. The initiation of bakelite can be done in two ways, by base catalyzed and acid catalyzed. So let's start with the first one, it is base catalyzed reaction. For the base catalyzed, what do we take? In the step 1, we take a phenol molecule. Now what is phenol? It is an acid. And we take a base, that is NaOH, that is sodium hydroxide. Now if you can see, student, there is a hydrogen atom of phenol and OH of sodium hydroxide. So there is an elimination of water molecule, and the product what we get is sodium phenoxide. But the sodium phenoxide, oxygen being more electronegative, pulls the electron from sodium and the bond dissociate, giving us a more stable compound, that is phenoxide ion. This phenoxide ion which we got undergoes resonance at first and second position to give us a double bond at the first carbon atom. Here we end with a step 1. In the step 2, what do we take? A formaldehyde molecule. This formaldehyde consists of a carbon and oxygen. Now tell me, which one is more electronegative, carbon or oxygen? Yes, it is oxygen molecule. So oxygen atom pulls the electron from carbon, forming an electrophile carbon with a positive charge and negative charge on oxygen atom. Yes, when this molecule reacts with the phenoxide ion from the first step, what will happen? The negative charge which is present on the second carbon atom will react with the positive charge of carbonyl carbon. So the resulting structure we get is the CH2 group attached at the second position of phenoxide group. This carbon at the second position of phenol ring consists of a hydrogen atom which breaks and attaches to the oxygen atom of the negatively charged oxygen. This undergoes tautomerism to give us a structure, that is orthohydroxymethylphenol. We get orthohydroxymethylphenol. So here we understood base catalyzed reaction. Let's see the second method, that is acid catalyzed reaction. In acid catalyzed, what do we take? In the step 1 is a formaldehyde. This formaldehyde on reaction with HCl, that is an acid, what will happen? The chlorine atom being more electronegative than hydrogen atom pulls the electron from hydrogen and it dissociate, and the oxygen atom of carbonyl group, which is more electronegative, will attack the hydrogen atom, giving us a structure with a OH carrying a positive charge and a double bond CH2. Since oxygen being more electronegative, it will pull the electrons present between carbon and oxygen, and what we get is an electrophile carbon with a positive charge. The next step will be, we take a phenol molecule, and this phenol at the first and second carbon undergoes resonance to give us a structure with a double bond OH plus and a negative charge at second carbon atom. The further step will be, from step 1 and step 2, what we got is a phenoxide ion and the formaldehyde with a positive charge on carbon atom will react. Now students, you know what is the next step? Yes, the negative charge on the carbon atom, that is a second carbon atom, will attack the positive electrophile carbon of carbonyl group to give us a structure which as CH2OH, the second carbon of the phenyl group. This undergoes tautomerism. How? The second carbon atom, which consists of hydrogen atom, dissociates, giving us H plus ion, and the OH minus will get an electron, giving us a CH2OH and H plus. This molecule which we got is orthohydroxymethyl phenol. So here there were two steps, from base catalyzed and acid catalyzed. We got orthohydroxymethyl phenol. We end our module here. Thank you.